Number 81. A microwave transmitter has an output of 5 watts and is 30 miles away from the receiving antenna. If the microwave system operates at 6 gigahertz and the antenna gains are equal to 20 dB, what is the received signal level in dB watts? Paano ang pagkuha ng RSL or received signal in dB? RSL is equal to the transmit power, i-add mo lahat ng gain, i-minus mo lahat ng loss. Okay? Yung transmit power, given na yan, that is 5 watts. Mamaya, i-convert natin yan into dB watts. Given na rin yung mga gains natin. Ang sabi kasi dito, the antenna gains, meaning sa transmitter and sa receiver, is 20 dB apiece. And then you have the FSL or the free space loss. So, unahin muna natin computen yung free space loss. Since this is in miles, this will be the factor that we're going to use, 96.6 plus 20 log of frequency in gigahertz, and that is 6. And 20 log of distance in miles, that is 30. So pag sinubstitute natin yan, this will become the equation. And of course, the value of the FSL will be 141.7 dB. Okay, now it's time to calculate for the RSL. Now, for the RSL, as I have said, the PT must be expressed in dB watts. So how do we do that? That is 10 log of 5 watts over 1 watt. 1 watt will be our reference because this is in dB watts. Plus 20 log plus 20 plus 20 dB plus 20 dB. These are the gains for the transmit and the receive antenna. Okay, minus the FSL, that's what we have computed a while ago, 141.7 dB. Therefore, the RSL will become negative 94.72 dB watts, and that is letter A. Okay? Okay. Next, question number 82. A receiver has a dynamic range of 81 dB. It has a 0.55 nanowatt sensitivity. Determine the maximum allowable input signal. Kanina pa natin pinag-uusapan yung dynamic range. And dynamic range is simply the ratio of the maximum allowable signal at the input of a receiver to the minimum allowable signal to the input of the receiver. Okay, so yung minimum allowable input to a receiver can be also called the sensitivity. So how are we going to solve for the dynamic range? That is simply 10 log of the output power over the input power. This will be the maximum allowable. This will be the minimum allowable. No? Actually, this should not be PO. Yun nga lang kasi para lang siyang comparison of powers. Therefore, nailagay PO over PI. But this should be the maximum and this should be the minimum. And we're looking for the maximum allowable input to a receiver. Okay, so how do we solve for that? That will be antilog of DR over 10 times PI. And manipulation lang siya nitong equation nito. And if we're going to substitute the values, that will be 81 dB, that's the dynamic range given, over 10, times 0.55 times 10 to the negative 9 watts, that is 0.55 nanowatts. Then we can now solve for the maximum allowable input signal, which is equal to 69 milliwatts, and that is letter B for number 82. Number 83, decreasing the quality factor of a resonant circuit causes its bandwidth to blank. Alam naman natin na ang Q and bandwidth are inversely proportional with each other. So, the decrease in Q will mean increase in bandwidth using this equation. Bandwidth is equal to the resonant frequency over the quality factor. Okay? Next, number 84. 1 nepper is how many decibels? So, conversion lang ito. 1 nepper is 8.686 decibels. Take note of that. 1 nepper is 8.686 decibel, or 1 decibel is equal to 0.115 neppers. So the answer is letter B. Next, an octave is an interval of ratio of two frequencies of what proportion? Now, when we talk about octave, we're talking about getting the frequency twice or one half. So that will be equal to letter D. 2 is to 1. Now, when we talk about decade, that is 10 is to 1 for decade. For number 85, letter D. Number 86, the core of an optical fiber has, ang nasa choices ay comparison of the refractive index. Okay? So ano ba yung core ng optical fiber? The core of the optical fiber is surely has higher refractive index than the cladding. That is letter C. Mas mataas parate. Usually kasi pag sinabi mong core, ang index of refraction niyan ay N1. This is for the core. No? For the clad, that is N2. And for fiber optics, N1 should always be greater than N2. So N1 has higher refractive index than the cladding. Okay, so that is letter C. Number 87. Parabolic antenna dishes are usually made up of, saan gawa yung parabola or parabolic antenna dish? And usually it is made up of aluminum, letter D. Okay, pakitandaan po yan ha. Baka maging surprise sa atin yan pagdating ng board exam. Pag lumabas yan, ako, huwag nyo ipagkalat. Okay? Yung pagkalat, baka madali tayo eh. Okay? Alright. Number 87. Number 88. A pulse modulation method where the analog signal is sampled and then converted to a serial n-bit binary code for transmission is what we call, this is what we call the true digital, this is the true digital pulse modulation. At kino-convert niya into bits yung converted analog signal natin. So, ang tawag natin dito is a pulse code modulation for number 88. Question number 89. With a PCM system with dynamic range of 199.5, what is the minimum number of bits used in the PCM code? Okay? So, tinatanong sa atin dito is the minimum number of bits used in the PCM code. No, dali lang naman siya, di ba? Na-solve na natin ito kanina. The answer is letter B. Okay? So, paano nga siya sinolve ulit? So, ang nangyari, ganito, no? For the dynamic range, this is equal to 2 raised to n minus 1. And this is 199.5 equal to 2 raised to n minus 1. And we're going to solve for n, and that is log of 200.5 base 2. And that is equal to 7.63 approximately. Since wala naman tayong 7.63, this is equal to 8. Okay? Now, kanina, nung sinolve natin ito, dinagdag natin yung sign bit. But ngayon, hindi natin dinagdag yung sign bit. Kasi ang sabi rito, what is the minimum number of bits used in the PCM code? Hindi naman niya sinabing sign PCM code. So, if we're looking for the quantized bits, that would be only 8 without wala yung sign bit. Ini-round off na lang natin ito into the nearest whole number for the number of bits. And that is letter B, 8. Okay? So, number 89, letter B. Okay? Next. Ayun pala, meron naman pala siyang, nagpakahirap-hirap pa ako. Okay, anyway, ganoon talaga. No? Number 89B. Next, number 90. With quantization, the sign magnitude code has a leftmost bit of 1. This means that the quantized level is, yan, sa PCM, paano mo malalaman na yung signal mo is positive or negative? Yung sampled signal mo is either positive or negative. So, meron kang sign bit. Now, yung sign bit mo, ang sabi niya rito, 1 yung leftmost bit, which is the sign bit. So, kapag 1, ano yun? Negative, positive, neutral, either negative or positive. That is positive. Kapag ang sign bit mo 1, positive yon. Kapag 0 naman, that is negative, of course. Okay, that is for number 19.